So hello and welcome to my session on what's new in Unity Catalog. Thanks for joining me. So just a quick introduction to myself. My name's Paul Room. I'm a staff product manager here at Databricks, and I've been spending my past few years building Unity Catalog, and I'm very excited to tell you about the latest updates. Before we get into the exciting content, I just wanted to say that there's a bunch of stuff in here which is new or actually currently in release. You're getting a sneak peek. So some of that might change before it hits your laptops. Excellent. So I wanted to begin with a short motivation behind Unity Catalog. We announced it at this conference 2 years ago, and we did so because we saw this fundamental challenge with the ways that organizations were managing their data governance practices. And the challenge went something like this. We saw all of these different data consumers, analysts, engineers, scientists, ML practitioners, trying to access data from all of these different systems. And the governance team was struggling to keep up. So if we take one element of governance, which is access control, on a data lake, they might be configuring permissions on files using cloud primitives. On data warehouses, they might be issuing SQL grants. And on AI platforms, they'd be doing something completely different. So we saw this opportunity to provide a unified governance framework which makes all of these different data consumers incredibly productive, while keeping the data governance team sane and, most importantly, in compliance. So I spent my last 2 years just speaking to hundreds of customers about how specifically Unity Catalog could help with their governance practices. And these 4 elements typically popped with all customers. So the first was that they all expressed they want their data to be secure and auditable. So we want to be able to assert a rule that says who can access which piece of data, and then to be able to answer fundamental questions such as who did access, who can access, and what did they do. Secondly, we want to make our data discoverable and give users the tools to discover that data. Thirdly, we want to make sure that our data is usable and performant, right? There's no point having broken tables out there that will just error when you try and query them. It's just taking up unnecessary storage space. And then the final one, we want to make sure that our data is accurate and high quality, because essentially people are making decisions off this data. So what I wanted to do in this talk is go through each of these 4 chapters and talk about the new features in Unity Catalog that help you address these, and some sneak peeks at some currently unreleased stuff as well. So let's take this first chapter of centralized access control for data and AI assets. And if you've spoken to Databricks over the last 5 years or so, you'll have seen some variant of this diagram, right? It's the data ingestion lifecycle. We take data from cloud storage, it goes through these levels of refinement, bronze, silver, gold, and then it's served out to end consumers. So if we're thinking about securing this from an access control perspective, we might want to start with tabular data, okay? And in Unity Catalog, we give you this really simple way to say, Paul is allowed to see all of the tables in this particular schema. But maybe your compliance team then comes back and says, well, Paul isn't that highly privileged. Paul shouldn't be able to see the columns which have sensitive data in them. So that's where our column and row level security comes in. You can assert that Paul can see all the data in the schema, but not anything that has sensitive data in it. And by the way, the green here means that this is a new feature that hasn't been generally released yet, but we have it in a preview format. And then we allow you to apply these tabular access controls to anywhere in Databricks where you have tabular data. So for example, in the machine learning world, we have something called a feature store, and you can use exactly the same methodology to secure the feature tables. OK, you may have heard this in Matei's keynote earlier, but we talked about tabular data. Let's talk about non-tabular data. And a really good framing use case for this is machine learning. So let's say we have some image files in S3. We want to use a model on those images. How do we do that in Unity Catalog? Well, volumes gives us a way to take a portion of our cloud storage system, like a prefix in S3. You register that as a volume in Unity Catalog, and then you can give access to that volume to individual users or groups, just like you would do with tables. If we take that use case forward, I want to use a model or train a model, well, I need somewhere to store that as well. And we're now really excited because you can put models in Unity Catalog as well. And this ensures that they're tamper-proof, no one can mess with them, as well as you can actually control who can execute those models as well. There's one other thing missing from this diagram, and for those large organizations, you might be wondering, well, it'd be great if all my data was in cloud storage. I have 100 back-end application databases which haven't yet been ETL'd into the lake. How do I get access to those? And this is where Lakehouse Federation comes in. So this is something that Matej just announced a public preview of, and it essentially allows you to register these other systems like Postgres and Snowflake, Postgres and MySQL in Unity Catalog, and then use all of these access control primitives on top of them. So to highlight this, I wanted to actually give a demo of what this looks like. So we're going to start with the Data Explorer. This is the place where we can see all of the different assets that we have registered in Unity Catalog. And in Unity parlance, each one of these things is called a catalog on the left-hand side. And you'll see a couple of different variants of them. I'll just point out a few. So the first thing I just wanted to point out is this one here. It's called Postgres. No surprises. This is actually just pulling from a Postgres database. OK, so if I expand it, then I should be able to see all of the different tables that are actually contained within that Postgres instance. And this is using the Lakehouse Federation technology that I just saw before. And then we have regular catalogs as well. The data here is just in cloud storage. So I have one here, and it's called my sandbox catalog. And if we're thinking about this from an access control perspective, the first decision I have to make is which environments do I want to be able to access this data? And an environment, if you know, in Databricks, that maps to like a workspace. So I can click on this tab over here, and I can configure exactly which workspaces should have access. So I've got 2 workspaces in my account, and I can choose to revoke one of those if I want to. Now, this is a really good way to achieve isolation between production and development environments, and it's something that can always be changed after you've configured it once. Excellent. All right, so we've configured environment-based access. Now let's go a level deeper. Say I've created a schema here. My schema just contains those different objects that we talked about before. Say I wanted to give permissions to my field team to access all of the objects in this sandbox I made for them. So what I do, I can click over on the permissions tab here, and I can just simply type the field team in, which is a group that I've synced in from my IDP. And I'm going to be really nice to them. I'm going to give them all privileges on this, schema so they can just go wild and do what they need to do. OK. So I gave them the ability to read all tables and those kind of objects in here. But what about if we need to go that level deeper? Remember, we talked about column level access control before. So let's launch my first notebook. So we're going to be looking at this element of access control, column and row level security for tabular data. And I'm just going to begin by showing you the before state of the table. So I've got this table called users here, and oh no, I'll suddenly see I've got email address in here, right? Maybe my field team shouldn't be able to see this. So what I can actually do is just go ahead and create a masking function. You don't need to read the code here. Essentially, all it says is, unless you're a member of this group called superadmins, you're going to get a masked value back. And then I'm going to apply that masking function to my column email. And then when I go ahead and select from my table, I should be able to see those masked values appear. Okay, so we're safe now. The field team can't actually see those email addresses. But the really cool thing here, you can apply this to not just the data in your data lake. You can apply this to those Lakehouse federated sources as well. So let me apply this and describe what's happening here. So in my Data Explorer view, you might have seen this one called Snowflake. So I've actually just registered Snowflake as a source of data in Unity Catalog. And now I can use all the same security primitives to actually manage access to that data. So I applied my masking policy to one of those Snowflake tables to mask the first and last name. And then when we run this command, we should be able to see that those results are actually masked here as well. So I think that's a really powerful concept. You can take all of those different sources. Unity becomes your governance platform to manage access to them. OK, so that's tabular data. We talked about something else as well. We talked about non-tabular data. So I wanted to just quickly demonstrate that. So let's go back to our schema here, field team sandbox. And let's think about that machine learning use case we talked about. I want to take image files. I want to use it with a model. What does that look like in Unity? Well, you can see here, I've got these volumes that I created in Unity. It's super easy to do so. You can just use the UI here. But I've got one here, and it's called dice images. And you can probably tell by the directory names. It's got pictures of cats and dogs in it, which I think is why the internet was invented. And essentially what I can do, I can just use exactly the same access control methods. So here's a dialog that helps me to, maybe I'll grant myself access to this so I can do my demo. So I'm going to give myself the ability to read all of this image data. Cool. And if we click on the models, we have a rather handy model here called the animal classifier. So you might be able to guess what I'm going to do next. But this is a model that's been pre-trained and registered in Unity Catalog. And now I can actually manage permissions to this as well. So let's do the same. Let's give Paul Room the ability to execute this model. Excellent. All right. So I have access to the images. I have access to the model. Now what do I do? Well, let's take a look at a quick notebook here. So we're looking at this use case of volumes and using it with models. The first thing I'll say is, just like in many other systems in the world, we've implemented a three-level namespace to find objects in Unity, and models are no different. So here, all I'm saying is I'm going to reference the model that we just looked at by this three-level namespace, catalog.schema.model. And then I'm going to read it into a function that uses MLflow. So you can actually pass these models from Unity Catalog into MLflow. And we're going to have a look at one of the images. So we've got this rather sad-looking cat that's missing an eye. And we're going to try and use our model to try and classify whether we can get this right. Cool. So it's churning along. All right. So maybe this doesn't have to be a state-of-the-art model to actually get this correct. But it accurately predicted that this is a rather sad-looking cat. The point wasn't the accuracy of the model. The point was that you can access control non-tabular data, you can access control models, and you can use the two of them together in Unity Catalog. Excellent. So let's go back to the slides here. The one thing that we just touched upon, I showed you a few features of it, but it deserves a deeper treatment, is the Lakehouse Federation. Definitely join my colleagues Todd and John, who are speaking about that today at 4:30 in a lot of detail. Excellent. All right. So I wanted to talk about one more type of access control on the source side. And this one I'm really excited about. So I've had a lot of conversations with customers recently that went like this. We love the features of Unity, but how can we get more data into Unity more quickly? And specifically, maybe you're a large organization and you've invested heavily in Glue or external Hive metastores for the last 10 years. It's not easy to just turn that off on one day. So I'm very excited about Hive Metastore Federation. And what this will allow you to do is to take your existing investment in Glue or in an external Hive metastore, register it in Unity Catalog, and then Unity will automatically crawl that metastore and populate the metadata. And then we can use all of the same security primitives that you saw before to actually manage access to that data as well. So we think this is going to be a really powerful interop story. And I wanted to give you a very early demo of this functionality as well. Excellent. So we're looking at the Hive Metastore Federation here. And the first thing I'm going to do is I'm just going to begin by initializing my catalog. And again, all this is doing, it's creating this catalog called Glue Federated. And it uses this connection object that I set up earlier that basically just points to your Glue instance. Okay? And I can look at my Glue instance in AWS. Right? This is what it looks like. There's a bunch of tables in it. And I can look at that glue instance in Databricks as well. So the same database is here. I can see all my tables. And then I can use it in a similar way to I would do with any other table in Unity. I can do select star from it. I can use the Unity access controls to grant selects on this to give them to my field users. I can even do fine-grained access on this. So here I'm going to use my same function as before to apply this, this masking function to a column. And if we scroll along this data set, we should be able to see a masked value come up. Lastly, if that wasn't enough, you also get Lineage, which is a topic that I'm not going to talk about until the end of the presentation. You have to wait a little bit. But just as a quick teaser, I'm going to just do the CTAS statement that basically just copies from this federated glue catalog to a regular table. And when I do that, you can actually instantly see the lineage for this table pop up. OK, so here's my federated glue table, and it's just been CTASed into this other table over here. We'll take a much deeper dive into Lineage in a moment. But the reason I'm really excited about this, if that wasn't enough, is the interop story. So let's say that I'm an Athena user. I don't know anything about Databricks. And I'm going ahead and creating data in here. So maybe I create a table called dice, and I go ahead and run that. And it creates the table, hopefully. Yeah, it created the table. If I refresh my glue catalog, I get this table called dice in there. And if I go back to my Databricks instance, I should be able to see exactly the same table pop up here, right? So it's a really good way to get that interop between the different systems while you're fully migrating onto Unity Catalog. Excellent. So that's Hive Metastore Federation. We've talked a lot about access control from the source side, but there's another angle to this, right? Perhaps you're working in an organization where there's a fairly distributed center of control, right? Like users are using Athena and Presto, and you can't really control what tools they're using, like in the previous circumstance. Well, this is why we're thrilled to announce both the Hive Metastore interface and Uniform, which you heard Ali mention in today's keynote, which open up Unity Catalog to the wider ecosystem. So with these interfaces, you can essentially use Spark and EMR and Athena and Presto to actually speak to Unity and to get data out of it. So we're really committed to making Unity Catalog part of this open ecosystem. I think this goes a long way towards it. OK, so to switch tracks just slightly here, for those of you who have used Unity Catalog, you'll know that there's these two different types of clusters that we support. One is a shared cluster. This is good for 90% of your use cases. Users share it. They pile on all together. We support all the fine-grained access control. And then we have these single user clusters, which the model here is if you want to do something slightly more advanced, like you want to use a GPU or you want to do distributed machine learning, then you break yourself out onto this cluster and safely isolate yourself. And our eventual vision for this is to unify the two types of clusters. But on the journey there, we're going to make improvements to both sides. So with UC shared clusters, you'll have seen a bunch of improvements recently. So things like the ability to install Python cluster libraries, do single-node machine learning, even streaming. And there's previews right now for Scala and NitScripts and jars. And also, really soon, we'll be allowing you to load a version of the machine learning runtime onto these clusters. But I mainly wanted to talk about single-user clusters. So if you remember, this is the type of cluster that you break out onto when you want to do something slightly more advanced. So let's say that you downloaded the latest distributed machine learning algorithm, bleeding edge from the internet, and you want to run it against your data. So you isolate yourself on the single-user cluster. And the challenge right now is to allow this kind of workload to work, we actually have to assume that the workload and the user has access to the full JVM and the full set of data on that cluster. This makes it really hard to enforce fine-grained security. And simply what we do today is we fail the query securely. So if you try and access data that's secured by fine-grained access control, then we'll actually fail the query. But what we're working on is actually a filtering service that will address this gap. So how this will work is when you do select star from a view or a table secured by fine-grained access controls, the data will be pre-filtered through this serverless filtering service, ensuring that only the records that you're allowed to see make it onto that cluster, meaning that you can both run arbitrarily complex workloads while getting the same level of access on your shared clusters and single-user clusters. So we're really excited about this, and there'll be definitely more announcements about this in the future. OK, so we've done chapter 1. Don't worry, timekeepers, that's my longest chapter. So chapter 2 is built into data discovery and search here. So I thought instead of doing slideware, we sat through the keynote for long enough, we'll actually take a look at a demo of this as well. So I wanted to start by giving you a view of how you can annotate your data. So I'm looking at a particular table in Data Explorer here, and we give you a bunch of different ways to basically describe this data. So the first one of those is tags, which is a private preview feature right now, which is just about to enter public preview. And I can simply add these tags to my table as an authorized user here, and then I can use them to search and classify my table and data. And you can also add them to columns as well. The second thing is these descriptions, right? So I can put a little handy description for my users into Data Explorer here, and you can use things like Markdown to make it look more pretty. And then the third thing here, Ollie actually mentioned it in his keynote talk, which is popularity. And you'll see this popping up in a number of different areas of Databricks. And for me, this it answers that fundamental human question, which is, am I alone? When I'm looking at this table, am I the only one that's looking at this? Or is there loads of people who've got knowledge about this table? So it really gives you that indication. We'll be using this in a bunch of different areas in Databricks, including in Lakehouse IQ, and then also in search ranking boosting algorithms and things like that. So let's say that I've described my data, and now I want to find it. How do I go about that? So you get this really handy search bar along the top, and you can search for anything. And the really nice thing here, it searches across all of these different types of entities in your Lakehouse. So notebooks, jobs, queries, tables, etc. I find this really useful to rip off other people's code, right? Like if you've downloaded an algorithm, you want to figure out how to use it, you can use this to search content in Notebook. But here we're actually finding a table. So here we go. And the final thing I wanted to talk about, well, I'll give a teaser. Well, obviously, Lineage is very useful for discovery as well. So I can look at the lineage of these tables and discover where they came from and the context of them. But again, that's a teaser. We're going to do much more in-depth treatment of Lineage in a second. The next one is actually table insights. So in this realm, we actually think we have a great advantage in Databricks in that we have lots of data about what you're doing. So every query that you run, we obviously know what you're doing. We know which notebooks you're using. We know what queries you're running against which table. And we can surface this to you in the form of insights that help you get started with your data. So as a new user, perhaps I'm struggling. This is a table that I've just found. How do I start making use of this? Well, we give you a list of all the most frequently used notebooks, and I can simply just open those up and start using them. Queries as well, so we give you SQL queries, dashboards that have been built from this. And then if you've outlived those, you can go and ask questions to the most frequent users of the table. And even things like most commonly joined tables, so if you're looking to augment your data, you're giving that as well. So we think this is a powerful insight. This is our first step into providing these insights, and we'd definitely love your feedback on this. Excellent. OK, so let's go into the third chapter, and this is performance and scalability. And typically, when I spoke to customers about this topic, the feedback that I got was, as a governance professional, we just want a macro way to ensure that the price performance in our lakehouse is always optimal. We've always had ways to basically increase the performance of tables by running optimized delta Z order or analyzed table statistics. But I don't want to leave it to the individual data engineer to do that. I want to apply a macro policy, which just means that I don't need to think about it. And that's exactly what predictive optimization does. So this is a lot of the tech, a lot of the results of the in-depth tech that Reynolds spoke to you about today in the keynote. Essentially what happens here, you turn it on for a Unity catalog, and then it will determine which tables need to be optimized, and go ahead and perform that optimization, choosing the right one to actually perform. So we think this is a big step forward. There's some really great results, and I implore you to check out the talk tomorrow at 2:30 by my colleague Siru on this matter. All right, we've been teasing it throughout the presentation, but I wanted to finally talk about Lineage and data quality. So if you haven't tried it out yet, in Unity Catalog, we've implemented this system of automatically capturing and tracking data lineage. And our vision here is to be able to describe all of the different relationships between entities in the Lakehouse. And we've made significant strides in this recently. So you'll see on the diagram here, I have an example of this little blob in the top left-hand corner. This is me loading from files, right? So I'm actually loading from a volume in Unity Catalog. And then secondly, you'll see the snowflake icon on there. This is me joining those files with a federated source, which is Snowflake. And then we've added a bunch more compatibility for things like DLT, using feature stores, and a whole host of other stuff. And we've seen some really interesting customer use cases on this front. So the big three would be automatic data documentation. This is really useful for discovery, right? If you're trying to understand what this table means, have a look at what sources it pulls from. Also, impact analysis. If you're a data engineer and you've been told you've got to deprecate this column in your table, who's going to scream at you tomorrow when everything goes wrong? And then finally, root cause analysis. So tracking down what went wrong when something does. OK, I'm going to give a demo of Lineage in a moment. But before I do that, I wanted to touch upon one more thing, which is Lakehouse monitoring. So if Lineage gives us a way to describe the relationships between entities in the Lakehouse, Lakehouse monitoring gives us the ability to really describe each entity in a lot of detail. So we're really excited about this. You can turn Lakehouse monitoring on for a table, and it will start monitoring it for data quality in an incremental fashion. So it'll look for things like drift in column. And then it will also, at the same time, do auto-classification of the data. So if sensitive values start to put into that table, then it will automatically select them and alert you of them. And it can even do things like monitor the model performance as well. But the reason I'm so excited about this is because of the combination of these two things. So we think about one of the use cases that we talked about before, which is root cause analysis. Let's say you got a buzz on your pager in the middle of the night because your model performance suddenly drops, a critical model for your company. And that's the model in the bottom right-hand corner there. And it's your job to basically figure out what went wrong. Well, if you're anything like me, what you want to do is start by assembling the sequence of steps that went to actually creating that table or creating that model. And that's exactly what Lineage is, right? Lineage is pre-built sequence of steps that created that model. And then if we're additionally running Lakehouse monitoring on all of the individual assets, you can start to pick out really good candidates for where I should go about my debugging. And in this example, we have these low severity data quality issues in the middle, and there's one up here as well. So this would be a really good place to start looking for root cause of my model performance issue. So I'm really excited about the combination of both Lineage and Lakehouse monitoring. OK, now the demo that I've been promising you on Lineage. So what we're going to do here, we're going to start by writing some Python code that just loads from an S3 volume and writes into a table. OK, so this is that code. It's chugging away. And it should be creating this table called sandbox users. The next thing we're going to do is take this table that we just created and join it with a Postgres table to create a feature table over here. So I prefer doing joins in SQL. So I just wrote a SQL query to do this. And you can see that I'm just joining this Postgres table to this users table that we just created. OK. And when I've done that, we can go ahead and search for our table. And we can view the lineage for it. OK. So you'll notice a couple of things there. The lineage was available in real time. So you just get it as soon as the queries are run. And then let's have a look at what's actually going on in the lineage. So here's our table. We can see we've identified it's a join between this Postgres table and this regular users table. And that users table was loaded from a volume as well. Excellent. We even give you things like column-level lineage. So if I click on an individual column here, you'll be able to see that this is actually a combination of first name and last name that went into this full name. So this is down to the column level as well. And there's lots of other bells and whistles to explore, like you click on a line and it will give you the notebook and the job that was responsible for that lineage. That gives you that full traceability of what happened. But what I'm most excited about here is the bit that I've been trying to hide from you by shifting the graph. Is this little icon over here, right? So actually, I cheated a little bit. During the keynotes, I actually trained a model using my table, using scikit-learn. And you can now see that we actually visualize models in a lineage graph as well. So this is an example of a model being trained from this feature data. So if we just zoom out a little bit, and we think about the vision that we're trying to accomplish with lineage, we're trying to describe the relationships between all of the different entities in the Lakehouse. We've actually come quite far. So on this small diagram, you can see data asset in files in the form of a volume, loaded into a table, joined with a federated source, and finally into a feature table, and then out into an ML model as well. So we are getting towards that goal of realizing end-to-end lineage for the Lakehouse. So we're very excited about that. Excellent. OK, so what we've seen today, went through these 4 chapters, and we looked at all the different features that would allow Unity Catalog to help make your data secure and auditable, as well as discoverable, usable and performant, and then accurate and high quality as well. So hopefully that has helped you to kind of understand some of our focuses for Unity Catalog and the roadmap there. But there's more, right? This year is going to be very exciting for Unity Catalog. Some of this was talked about in the keynote. Things like Lakehouse IQ are going to revolutionize how we do search and discovery in the platform, as well as Lakehouse monitoring that's going to be helping us do the auto tag and mask, and the improved observability through the governance portal. Excellent. So that's pretty much the end of my talk. I just wanted to leave you with these few recommendations from myself. These are talks that you should check out. Lots about Unity Catalog in this conference. So I hope you've enjoyed my talk, and please enjoy the rest of the conference.